Our universe is not static, it is in a constant state of expansion. Space itself stretches endlessly, making it nearly impossible to define a true boundary or measure its full size. Yet thanks to groundbreaking observations from the James Webb Space Telescope, JWST, we can now gaze farther into the cosmos than ever before. Since its launch, JWST has revealed astonishing details about distant galaxies, stars, and the structure of the universe. Experts like physicist Brian Cox and many others have emphasized that what we currently observe is only a sliver, a tiny glimpse, of a potentially infinite reality. Within the part of the universe we can see, astronomers estimate there are about 2 trillion galaxies. And that's just what we've been able to detect. The actual size and contents of the universe could be far greater, stranger, and perhaps without limit. As the late Carl Sagan famously said, "We are a way for the universe to know itself." Every image JWST sends back helps answer one of the most ancient and profound questions. How vast is our universe, really? Let's step back and gain some perspective. If you were to drive at 70 miles per hour, it would take 15 days to circle the Earth's equator, 5 months to reach the Moon, 63 years to reach Mars, at its closest, and over 4,000 years to reach Neptune. Now consider Voyager 1, launched in 1977 and traveling at 38,000 miles per hour. Even at that incredible speed, it took 35 years to exit our solar system. Yet even light, the fastest thing we know, circling Earth 7 times in a second, struggles to cross the unimaginable gulfs of space. Our solar system is vast, but it's only a speck within the Milky Way galaxy, home to roughly 300 billion stars, many of which host planets. Our closest neighboring star system, Alpha Centauri, lies 4.3 light-years away. At Voyager 1's speed, it would take about 70,000 years to get there. Take the star Betelgeuse, for instance, located 640 light-years away. The light we see from it tonight actually left the star more than 6 centuries ago, long before modern civilization. Our earliest radio broadcasts, humanity's faint whisper into the void, have been traveling for just over 100 years, forming a bubble scientists call the radiosphere. This bubble is about 200 light-years wide and has only touched a tiny fraction, around 15,000 stars, out of the hundreds of billions in our galaxy. Now imagine shrinking our entire solar system to the size of a small coin. In that case, the Milky Way would span the size of the entire Earth. And beyond it? At least 1 trillion more galaxies. To picture that number, 1,000 groups of 1,000 cats gives you 1,000,000 cats. 1,000,000 such groups equals 1 trillion. Our neighboring galaxy, Andromeda, is around 2.5 million light-years away and is on a slow-motion collision course with the Milky Way. When they finally merge billions of years from now, actual star collisions will be rare. Space is that empty. Zooming out further, we find ourselves part of the local group of galaxies, which in turn belongs to the Virgo cluster, home to 1,500+ galaxies, and even beyond that lies the Laniakea supercluster, containing over 100,000 galaxies. Yet even this colossal region is just one among millions of superclusters in the observable universe. But here's where things get even more fascinating. These galaxies and clusters are not scattered randomly. They are arranged in cosmic filaments, vast, web-like structures made of gas, dust, dark matter, and galaxies. These filaments stretch across billions of light-years, forming the cosmic web, the very backbone of the universe. Between these threads lie cosmic voids, immense, seemingly empty regions. Some are hundreds of millions of light-years across. But these dark zones are not meaningless. They may one day become fertile grounds for new cosmic evolution as matter slows. At the very core of the universe's grand performance lies a breathtaking cycle of birth, transformation, and death. Stars, forged from swirling clouds of gas and dust, ignite into brilliance, burning for millions or even billions of years. These celestial furnaces produce the heavy elements, carbon, oxygen, iron, that are the very building blocks of planets, oceans, and life itself. When their fuel runs dry, some stars die quietly, fading into white dwarfs. But others go out in a spectacular finale, a supernova. These colossal explosions briefly outshine entire galaxies and scatter enriched material across space. Every atom in your body heavier than hydrogen was born in such an explosion. In that sense, we are all, quite literally, made of stardust. But the universe doesn't stop there. In the wake of stellar death, some remnants collapse into black holes, regions so dense, their gravity warps space and time itself. Not even light can escape. And yet, these mysterious objects do not simply consume, they also shape. Anchored at the centers of most galaxies, supermassive black holes control the formation of stars, influence galactic structures, and even power jets of energy that stretch for thousands of light years into intergalactic space. Some of the most awe-inspiring objects in the cosmos are quasars, brilliant, ancient beacons powered by supermassive black holes devouring vast amounts of matter. As gas spirals into the black hole, it heats up and shines brighter than entire galaxies. These distant lighthouses serve as time machines, allowing us to peer into the universe's distant past, revealing the turbulent childhood of galaxies. All of these wonders, stars, black holes, galaxies, filaments of gas and dust, are part of what we call the observable universe. It's everything we can detect, measure, and study with our current technology. But here's the cosmic twist. This observable realm is likely just a small patch in a far vaster reality. There are regions of space so distant that their light has not had enough time to reach us, even traveling at the speed of light since the beginning of time. And because space itself is expanding, those galaxies are being carried away faster than light can bridge the gap. These galaxies are not just distant, they are forever unreachable. They lie beyond what scientists call the cosmic horizon. This expansion isn't slowing down. It's accelerating, driven by a mysterious force we call dark energy. Because of this, more and more of the universe will slip beyond our ability to ever see or know. In time, even some galaxies we see today will vanish from view, lost to the dark. So how big is the universe, really? Using the tools of physics and mathematics, cosmologists estimate that the actual universe may be at least 250 times larger than what we can currently observe. And some theories go even further, suggesting the universe might be truly infinite, with no edge, no center, and no end. This realization shakes our sense of scale. We live on a fragile world, circling a modest star, in a spiral arm of the Milky Way, which is just one galaxy among trillions. Our entire observable universe may be a mere island in a vast cosmic ocean, the full size and shape of which we may never fully grasp. And yet, within this grand immensity, something remarkable has happened. Out of clouds of gas and ancient starlight, life emerged. From matter came consciousness, capable of wondering, dreaming, and asking why. We are not just spectators of this universe. We are participants. The atoms in our bodies were forged in ancient stars. The thoughts in our minds arise from processes governed by the very laws that shaped galaxies. We are a way for the cosmos to observe itself. So as we look up into the night sky and ponder the vastness of it all, we are reminded of a humbling truth. Our existence is rare, fragile, and profoundly meaningful. In a universe so ancient and immense, curiosity, awareness, and life may be the most extraordinary phenomena of all. We may be